Hello, my name is Gabriel Rogers. I'll be going over Project 3, 5 Things I Like the Most from Design to Manufacturing. This is for the Fall 2024 class, and this will be submitted to Dr. Hassan Rashidi for the Georgia Institute of Technology. I'll be going over the topics of lean manufacturing, the industrial Internet of Things, virtual twins, CNC, and retrofitting. Now, for each of those topics, I'll be giving a summary, the applications of each topic, the capabilities and limitations of those topics, and why I like them. I will then give my resources, and then I will conclude this slideshow. The first topic is lean manufacturing, which is a methodology for both business and industry that focuses on minimizing waste within manufacturing systems while simultaneously maximizing productivity. And this is driven by operational efficiency and customer satisfaction. Basically, how can we be as efficient as possible and provide as much customer satisfaction? And this goes into principles of figuring out what is valuable, how can we get the value, how are we going to make that value flow as efficient as possible, figure out where to set those up to be efficient, and then continuously improve. Um, So for applications, this can apply to any industry, especially in the business and manufacturing sector. Uh, I'll be focused on the manufacturing sector mostly. It goes into automation, the continuous improvement mentality, goes into flexibility. Basically, can we rotate as efficiently? And then we'll go to production flow, because of how lean manufacturing works, there has to be a lot of controllers and advanced systems to maximize the efficiency. So it has to adjust its flow to maximize how effective it is in per sections. And then supplier relationships, are we going to have a port nearby? Are you going to be able to ship them efficiently and effectively and cost effectively? And one easy example of that is a car manufacturing plant where they actually roll down the vehicle being made on an assembly line, and a lot of that is automated or assisted where it's always moving, and so it's always keeping this production flow going and moving at all times. Some of the capabilities or pros of lean manufacturing is it reduces lead times. It also it reduces operating costs. It improves product quality, and it simplifies process or tools. One of the main parts of lean manufacturing is, well, you're leaning out the manufacturing. How little parts, resources, people do you need? You know, how efficient can you make the process of manufacturing? So your your goal is to use as little as possible. However, that also comes to problems in the future where you could hinder future development because you might not have tools to change a lot, or you just have small error margins because you don't have all these extra fail safes due to you having a lean and not as robust manufacturing process, trying to be as efficient as possible. So your failures could stop the entire system, and it could really slow the assembly line when the manufacturing breaks down, like a tool breaks or something like that. So why I like lean manufacturing is it really reminds me of this game I play that's all about efficiency and maximizing resources, resource management, and it's kind of just it's a fun game, but it's a lot about how are you going to gather these resources, how are you going to ship it to a place that's going to manufacture it as effectively as possible to complete the goal of the end goal is of manufacturing. So it's not like selling it, but it's a lot about resource management, how you're going to move it, and operating times. So that kind of got me into engineering, and it kind of the lean manufacturing idea really resonated with the kind of the same reason why I really enjoyed this game. So a good segue from lean manufacturing is the industrial Internet of Things, IIoT, and it pretty much supports and benefits lean manufacturing, so it's not too far. Um, It's a closed loop system that basically includes sensors and a bunch of other, machines, process, materials, supply chain maintenance, all about just increasing the operational efficiency and productivity, quality of the manufacturing system. So the biggest application of the industrial Internet of Things is just automation, and this includes the at the plant and out of the plant. This is the entire product life cycle of almost anything being manufactured could benefit from this. Basically, ground to raw materials all the way up to the customer can be optimized. That's why industrial engineering is such a big field right now, is because it's all about you can optimize from where the resource is going to the plant, to how efficient the plant moves it, to how efficiently you can deliver it, and all this stuff that allows you to just be efficient from start to finish. So for capabilities and limitations, capabilities are using the industrial Internet of Things, basically hooking up to the cloud. You have real-time monitoring, data collection, analysis, decision making. It can predict maintenance because it's watching how much it does. So if you're running it for maybe it's set up. You basically have to set up an algorithm like every 100 hours this tool will probably need to be replaced. Then you can maintain it before something breaks. So instead of you're just swapping it instead of the whole line failing because a part broke already. This also bleeds into automation, where it allows to just run continuously. And then also, because of automation, you're allowed to do remote control, which means you can do in lights out conditions where basically there's no people there or very limited, just a skeleton crew just to keep it running. Or you can have manufacturing in hazardous or dangerous conditions that humans would not be able to easily perform in. Some limitations of the industrial Internet of Things is cyber attack risks. Um, some of the just dams and systems are always under attack. I think one of the dams in the West gets almost 100,000 cyber attacks a day. So there's a lot of risks. If that fails, it could cause a lot of problems. And then there's another thing is complexity. Since you have all these sensors and stuff, there's a lot of complexity, and with that, high costs of implementing those effectively. And then since this can all be monitored remotely, possibly, or some of them operate remotely, you'd have issues like CloudStrike, which is basically the cloud failed and the entire system shut down. So I'm referencing Delta. Delta Airlines basically shut down for 2 weeks and didn't know where any of its members or its crew were because of this failure of the cloud. So that just, although it's more efficient, if something breaks, it can be really bad. So, same reason I like lean manufacturing. I really like Satisfactory. I'm not going to go too much into that. So the next thing is virtual twins, which is actually pretty similar to the first two. So we're not moving too far off, but it's basically virtual replicas of physical assets, processes, or systems to use real-time data to simulate, analyze, and predict behaviors in digital space. The lean manufacturing basically heavily relies on virtual twins for modeling and simulation of plants and factory automation. But virtual twins also includes CAD, computer aided design, and a lot of more of design process, not just the automation process. But it's used across for almost everything: design, maintenance, efficiency, and decision making. So CAD's one of the biggest ones, but you can do smart planning. Basically, it can help you route how much flow needs to go somewhere. It's very popular in HVAC. Basically saying how much air do you need to get here, and it can you calculate how big a pipe you need to send fluid across. It's really cool. Factory line, it can kind of model how long each thing will take and allow you to figure out kind of how to set up your factory line. Capabilities and limitations. Basically, same thing, pretty much with the other with industrial Internet of Things. And lean manufacturing allows real-time monitoring, data collection, analysis, decision making, predictive maintenance again because it can model and simulate it, and then automation. So limitations though are a little bit different. basically it's a data dependency. If you get wrong data, since it's an algorithm, it'll hurt the reliability of it, and it's also very complex, and with complexity comes costs. So why I like virtual twins is I use CAD a lot for prototyping, and I could not imagine the amount of time that I would have. Like I cannot imagine how much time more it would take to design some of the complex simulations or modeling I've done. It would just be so much more work and hours put into something that I can just easily ask the computer to simulate all the hard stuff. So moving on to computer numerical control, or CNC as it's well known. Basically, it's technology used to control machining tools and equipment through a computer system, and the program to perform cutting, drilling, milling, turning tasks, basically simple manufacturing tasks with a very high precision rate. It's like to the thousandth of a millimeter or a thousandth of an inch. So the applications are, like I said, complex or precise manufacturing. So make very complex shapes that would not easily be able to make out of like forging or casting. And then it's very precise. So again, to a thousandth of an inch or even greater or even more precise. This also is great for custom designs or prototyping, especially used in like space and aeronautical stuff where they're making very high precision. Has to be this exact shape. It's a very irregular shapes as well. So these are very popular. So again, its capabilities are high precision, accuracy. It can be automated. There's efficient. It can make perfect efficiency since it can actually like see its path and it will follow the perfect path to cut it. It can cut complex geometries and it's very repeatable because you just hit restart on the same block of metal. Start, and it works on multiple materials: metal, wood, plastic, etc. Limitations is it's a very expensive machining and the tools expensive. Maintenance is expensive. It takes a lot of high skill to program and operate them. And then there's a material waste since it's a subtractive manufacturing process. There's a lot of waste that comes with that. So I like it because the precision and using machines to make like perfect fits is super cool. There's like a zero tolerance cubes and stuff that like they don't actually cut through it exactly, but like it shows just how precise you can truly make these. Um, and then I like cars and I like planes a lot, and there's a lot of CNC and just really cool to see how things are made. And I really like seeing how that works. So the last topic I have is retrofitting. It's the process of updating or modifying existing equipment or facilities to improve performance, efficiency, and sustainability. So like adding new parts, integrating technology, improving the energy systems, which basically making it more efficient, safety features, and improving connectivity, or also known as modernizing. Basically, like a, a lot of companies are trying to implement virtual twins and implement the industrial internet of things, and that allows it to like connect it to the cloud and allow it to be automated. So the application is like equipping, so like sensors, cameras, computer systems that enable them to connect to the cloud, like I said. But those computer systems allow them to be modified for maximum efficiency and use some of the previous uh, topics we discussed. So pros: increases speed, quality, efficiency of production. Can improve safety. Again, it allows for automation. A lot of the failures though with auto or cons of retrofitting is that there's a lot of functional failures with aging systems, and you could be overloading parts that are not doing what they're originally intended to do, and that can also sacrifice features. So if you have a newer, better, more powerful like radar, it might take more space, and that means you might have to cut material or some another electronic component out to make room for that giant radar. So, good. Why I like it. So I'm going into the military, and this is one of the planes I'm looking at flying. But this plane has been flying since 1954. This thing's ancient. But we have made newer technologies and retrofit it to stay modern. So the newest one is a C-130J from the C-130. It's like sixth generation of this plane, and so it's been retrofitted, modified to have better engines, more efficiency, right? But then they took it even farther. They retrofitted it for certain scenarios. So LC-130J has skis on it to land in Arctic conditions, has a lot of anti-frost stuff. The AC-130J is specialized for combat, and so it has a bunch of guns on it and flares. Looks really cool. MC-130J is C-130, smaller blades. It's meant for low-level flying. It can actually refuel helicopters, and it has a terrain scanner. So, and it's actually like attachment on the nose. So it's literally, instead of like taking material away from it, they literally cut and made a bigger nose for a terrain scanner. The KC-130J basically got rid of all cargo space and made it put fuel cells into it, and then added additional fuel cells on the wing, so it can fuel fighters and other planes in air. And these are the resources I used for all the all the topics. In conclusion, I went over all the topics like lean manufacturing, industrial Internet of Things, virtual twins, CNC retrofitting, and I went over the resources I used. That concludes my presentation. Thank you and have a great night.